This session's about new LookML features and development practices. My name's Alexandra Alexic, and I'm a product manager with Looker at Google Cloud.
I'm Erik Eintare, and I'm head of analytics platform at Bolt Technology.
Today's agenda is going to focus on first going over some of the new LookML features we recently released, and then I'll hand it over to Eric from Bolt, who's going to talk about how they use Looker at Bolt and also how they're taking advantage of some of the new LookML features. Before I talk about how we've improved our data transformation workflows in this last year, I wanted to first get into why data transformation in Looker is different and how we empower analysts and reduce time to insight. So when you think about Looker's modern data approach, it's a different way of thinking about data transformation from collection to consumption. So our approach empowers analysts and really focuses on getting you value from your data faster and reducing that critical time to insight. So with Looker, you still need to do data cleansing, data normalization, but what you can do is actually simplify this process. You can take your data, put it in your data store, and you don't actually need to reduce the data granularity to get quick insights. So that's the joy of Looker, that you can drill into the data, you can get those super granular insights that you need to make good decisions. So with Looker, you have the ability to run ad hoc queries directly against your database and also leverage Looker's transformations to get the most out of your data and improve performance, especially with super expensive or frequently run queries. This year, we released a new feature called Incremental PDTs. This feature expands on our persistent derived table functionality and makes it a whole lot more powerful. If you have large persistent derived tables that take a long time to build because they have to be rebuilt completely each time you get new data, this can really help streamline your workflows and reduce your build times. So what you can do is basically by using the parameters to define incremental PDTs, you can basically append fresh data instead of rebuilding the whole table. So what you do is you define a transformation and then define a time frame for it to incrementally build along. We also introduced a mechanism to account for late arriving data. So say you're worried about, you want to define an increment to build, let's say daily, but you're worried that maybe you get a few records from 2 days ago that somehow get introduced and you're afraid they're not going to be included in the table itself. So what you can do is by using this offset mechanism, you can actually go back in time and it will rebuild those past few days depending on how you configure it. So you can account for late arriving records and rest assured they're going to be included in your persistent derived table, even if you're building it incrementally. And we do support it for all types of persistent derived tables, whether that's native, so the LookML based variety, SQL based, and we also support it for aggregate tables as well. So our incremental PDTs are configured in quite a straightforward way if you're using our native LookML based persistent derived tables. So you can actually define an incremental PDT with just one parameter, which is the increment key. So the increment key is a dimension, so you can perform a windowed query and append fresh data to your persistent derived table. If there's a chance, for example, that you sometimes get late arriving data, we have a secondary parameter called the increment offset, which can then trigger a rebuild of previous data in your persistent derived table to account for any late arriving records that you want to make sure are included in that larger persistent derived table that you've defined to be incrementally built. So if you get started with incremental PDTs, native derived tables are the best landing spot to give it a go because Looker handles a lot of the complexity for you. Of course, we do support this functionality as well for SQL-based persistent derived tables, but you have to take a few additional steps to implement incremental PDTs. Next, we're going to talk about how do you identify a good candidate to be converted to an incremental PDT. So there's a few different things you have to think about. So you need to use incremental PDTs with tables that have immutable rows. So for example, event stream tables. You don't want to you can't convert actually a table to incremental if you have data way back in time changing regularly, because then the whole table will need to be rebuilt to ensure you have accurate data. So really keeping in mind that you need immutable rows is a smart thing to do to ensure that your data stays accurate and the incremental PDT works as expected. The table also needs to be persisted. It can't be a derived table to be built incrementally. So you need it to be a persisted derived table. And you also need to have a timestamp column, because that's what we use as a reference point to incrementally build along. And a great starting point actually to identify candidates for incremental PDTs is system activity. So if you go to the PDT overview section of the system activity database performance dashboard, you actually have already a pre-built tile that it shows your PDT average build time. So there you can see which PDTs are maybe taking longer than you'd like them to build. And as long as they meet these other criteria, that would be a good starting point to take a look at to think about converting to incremental. Another feature we released this last year is the ability to persist your derived tables as materialized views. So this allows you to keep your semantic model in Looker, but take advantage of your database's materialized view functionality to persist your derived tables. So this means that the database, rather than Looker, is responsible for rebuilding the materialized view. So it's also a one parameter change. So you need to specify materialized view yes for a native derived table or a SQL based derived table. And then the database will take over and ensure that the materialized view is rebuilt. Currently today, we only support this for 2 dialects. So it's supported for BigQuery and Redshift. Another feature we released this year is visibility into the build state of development mode PDTs. This is a feature I personally am very excited about because it gives you up-to-date, reliable information directly in your development environment, where you can see the state of your persistent derived tables before you push them to production. So you'll be able to basically see whether or not it's built, whether you need to trigger a PDT to rebuild, and ensure that it's fully built before pushing it off to production. We also added, related to this feature, we also added another tab in the PDT admin page where you can also see the same information on into build state, and also a lot more detailed information that for the development mode PDTs, just like you were already able to for the production PDTs. So just giving you a lot more visibility and control in the development environment so you can understand what's going on in your system. Next, we're going to talk about some of the enhancements to query acceleration. One feature that's been in the product is aggregate awareness. So Looker uses aggregate awareness logic to find the smallest, most efficient table available in your database to run a query while still maintaining accuracy. So with aggregate awareness, you can pre-construct aggregate tables to various levels of granularity, dimensionality, and aggregation, and you can inform Looker of how to use them with existing explores. Aggregate tables themselves are defined in LookML and materialized as persistent derived tables. As soon as the table is defined, Looker will use it automatically whenever mathematically possible. So this can result in faster, cheaper queries. Depending on the question you ask Looker, with aggregate awareness, Looker's going to know to optimize and use the smallest table possible to answer your question, which is what results in the query acceleration. So if you think about asking the question, what products sold most in the Houston store last month? Aggregate awareness can then route your query and answer it using the smallest table from the tables that it can select from below in the graphic. If you ask which region had the lowest sales yesterday, it's going to route you directly to that daily sales by region table. So it reduces the amount of data it queries. We've added some enhancements to aggregate awareness to make it easier to use than ever before. So we can generate aggregate tables more efficiently. So when we suggest LookML for the aggregate tables, now we can ensure that it's validated against the model. So for dashboards, we either report aggregate tables that will optimize, and if not, we report why they won't optimize. I already mentioned it earlier in the presentation, but we also can now build aggregate tables incrementally. So when you have these large aggregate tables, you don't have to build them in their entirety. So you can leverage that incremental PDTs feature and apply it there. We also, for aggregate awareness, increase the hit rate for filtered queries. Leveraging Looker and BI Engine together gives you many advantages. So BigQuery is actually the #1 data warehouse used by Looker customers. And with BigQuery's BI engine, you're able to take advantage of many layers of query optimization. So BI engine itself has a lot of advantages. It can deliver sub-second query speeds. It tunes itself automatically, so it manages what data it moves from memory to cache and disk storage. And there's no need to extract or move data. So you don't have any cubes or anything like that in your BI layer. In addition to aggregate awareness, if you are one of our customers who is using BigQuery, you have the option to take advantage of Looker and BI Engine together and benefit from some of the acceleration that BI Engine can do. This year, we added support for 2 new dialects. We added support for Google Cloud Spanner in Looker 2114, so you no longer need a custom JDBC driver to connect, and you can take advantage of improved SQL generation abilities for Spanner. We also added support for Firebolt this year as well, so you can take advantage of that connectivity if you're using Firebolt as your database. Both Firebolt and Spanner have documentation and configuration instructions available on our website and have all the benefits that you'd expect from a Looker-supported dialect. I'm going to hand things over now to Eric, who's going to talk about how Bolt uses Looker and also about some of the new LookML-related features they're taking advantage of.
Thank you, Alex. And here's a little intro about ourselves. So who am I and what is Bolt? I'm Eric Heintare. I've been working for more than 10 years with the data. Those last 4 years, I've been working at Bolt. I joined as the first data analyst for the company, moved over to analytics manager position, but then decided to be more hands-on, and now I'm building our analytics platform for 100 data team members and thousands of internal users. What is Bolt? Bolt is an European super app which started off as a ride-hailing company in Estonia that now serves more than 75 million customers all over Europe and Africa. We're valued over 4 billion euros and we're aggressively hiring, and we have more than 700 open positions. So firstly, how we use Looker at Bolt. Some of the stats of us. We implemented Looker 4 years ago as our main BI tool to get our management and all the operations people to get rid of Google Sheets. We now have more than 2,000 internal users who generate more than 300,000 queries daily. And we have done it all with one administrator, thanks to a lot of automation with user generation and control of the dashboards, folders, and everything. We don't use Looker as a BI tool only. It's one of our main ETL tools. It's also an internal tool for some of the customer support and operations people. We use the data enrichment capabilities with Looker Actions through Segment. And also our software engineers take advantage of the API to enroll users to certain campaigns or to automate some of the tasks. And lastly, we use it as a last line of anomaly detection. And now to some examples of how we take advantage of the new LookML features that Looker has provided us. So firstly, incremental PDTs. To give you a better understanding how we use PDTs, just a general overview. We have around 400 PDTs in total, and before incremental PDTs, the heaviest ones reached up to 60 minutes. After we introduced this feature to our instance, we're peaking below 10 minutes for the heaviest queries. So it helped us to go from 60 minutes to 10 minutes with just a couple of days of work. And now we use incremental PDTs whenever it's possible by default. On top of that, I wanted to give you an overview of Looker versus Airflow and how we use it. So initially Airflow was our main ETL tool because Looker didn't have incremental PDTs. But Airflow has a big entry barrier. But thanks to Looker incremental PDTs, we have solved 90% of the cases where we needed to switch from Looker to Airflow. And now only the ETLs that are used heavily outside of Looker are built in Airflow. Second new feature that we use is Aggregated Awareness. And to give you an example of how we use it, we had one example of commerce reporting where our analyst built a query that was really heavy. And on average, it ran around 8 minutes. It was really complex, containing a lot of cross joins, everything. Storing the entire query as a PDT would have taken us 45 trillion rows. So it's not possible, at least in our scale. What we did instead, we used Aggregated Awareness to support majority of the use cases. And what we achieved with it was that our query runtime is now less than 2 seconds. We need to store results for only 300,000 rows, and it's super easy to support new use cases around this topic. Finally, I want to give you an overview of some of the other new features that we use. Quick Start and materialized views. So Quick Start is something that we're now expanding to all the biggest explorers that are available for our business users, and also to the most used PDTs. Regarding materialized view, since we use Redshift as our data warehouse, it helps us to get the freshest data without any manual setup for the PDTs. And that's it. Thank you for joining in. And if you want to learn more about, then we have listed a couple of links here to learn more. Thank you once again.